These problems are a little harder than the Math Review Part H, but I'm going to use the same technique that I used in my video for Math Review Part H. Here there is a volume, and there's a lot of information here. Got 1.5 centigrams, got 2.70 grams per cubic centimeter, and we want to know what the volume was. Okay? Now, because there's more than one piece of information given here, I don't know where to start. Should I start with this number, or should I start with this number? Where should I start? In a case like this, I like to start with what you want. And here, it says you need to get the volume in milliliters. So we want milliliters, all right? So I'm going to start with milliliters. I'm going to put ml. Now, I need a way to get ml. So how is ml related to this problem? It's related to this problem in this way. 1 ml equals 1 cubic centimeter. So 1 ml, 1 cubic centimeter. Notice I'm starting with the conversion factor, which is kind of weird. The reason why I'm starting with the conversion factor is because I want to start with what we want, which is ml, and I want to make sure that what I want ends up on top. So now I have to get rid of the cm cubed because I don't want cm cubed. At the end I want just ml. So here's cm cubed right here. So this is cm cubed underneath a g. So if I want to put cm cubed underneath a g, it's going to look like this. But you can see that's not going to help me because I want to cancel out cm cubed. This arrangement for this this conversion factor is not good for canceling out the cm cubed. I'm going to end up with cm to the 6th power here. So I need to flip this upside down. I need to put the 1 cm cubed on top and the 2.70 grams on the bottom. Now, how did I know it was 1 cm cubed? If you don't know that, you got to go back to the Math Review Part H video. Now, 2.70 grams per cm cubed, that's a density. How come I could use it as a conversion factor? You could actually use anything you want as a conversion factor, as long as the relationship is there. Okay? So, these guys cancel out. That's good. Now I have ml. That's good. But I have grams. It's not good. I don't want grams. I want the final answer to be the ml. So how do you get rid of grams? Well, here we go. 1.5 centigrams. Centigrams. Well, that means I'm going to have to convert grams to centigrams. So here I go. 1 times 10 to the minus 2 grams is 1 centigram. Now, how did I know that? Where did I get that conversion factor? I've arranged it properly so grams can cancel, but where did I get 1 times 10 to the minus 2? That's something that you need to memorize before our exam quiz. This is a table of prefixes that you need to memorize. These are not all the prefixes that exist, but these are the ones that you need to memorize for Chem 65. Let me show you how to use this table. These are the prefixes for metric or SI units. SI stands for Système International. It's French, but these are just the prefixes. After these prefixes comes the base unit. So here, CG. G is the base unit, and C is the prefix. You see that? So over here, C, the prefix C means 0.01, or 1 times 10 to the minus 2. So how do I use that in a conversion factor? Well, the 1 goes on the prefixed unit, 1 Cg. And then 1 times 10 to the minus 2 goes on the base unit, G. Now I know what you're thinking. You're thinking, why did he write 1 times 10 to the minus 2? Why not just write 10 to the minus 2, the way it says in here, 10 to the minus 2? I put the 1 times 10 to the minus 2 because I'm going to eventually use a scientific calculator for this problem, and on the scientific calculator, it's much easier to type 1 and then the scientific notation button, and then -2. If you type 10 to the -2 power, that's just harder to do on a scientific calculator. So, some of you are thinking, why bother with 10 to the -2 in the first place? Why can't you just type 0.01? Yeah, that's okay too. I could just put 0.01 g, and I would still get the right answer. You could do it any way you like. I prefer 10 to the -2 because some of these numbers get really long, and it's easy for me to make a mistake with the numbers of zeros there. So let me show you how this is not done. I have a lot of students usually who try to set up the conversion factor like this. 1 gram is 1 times 10 to the -2 cg. This is not right. The 1 doesn't go on the base unit. The 1 goes on the prefixed unit. So the 1 goes here. The 1 times 10 to the -2 goes here. If you're going to memorize this table, and I think you should, and if you're going to use this table, you have to do it this way, with the 1 on the prefixed unit, and the thing that's not 1, that goes on the base unit. Okay? Now in Math Review Part H, that was not the case. We did not use this table in Math Review Part H because you hadn't had it before. So in Math Review Part H, there was a different set of given conversion factors, and in that set of given conversion factors, you didn't have this pickiness with 1 going on the prefixed unit and the thing that's not 1 going on the base unit. But if you're going to use a table like this, then you have to do it this way, with 1 on the prefixed unit and the thing that's not exactly 1 on the base unit. Okay? Alright, so now I've got CG on the bottom here, and that's not okay because I don't want CG at all. I want the answer to be in milliliters. So, let's see, where can I find CG? Here it is, 1.5 CG. This number is in the problem, not related to any other number. It's not like CG per cm cubed, or it's not like CG equals something, so I can just write it by itself. 1.5 CG. 1.5 CG. So those of you who like math, you could just put this over 1 if you want, or those of you who are just like the rest of us, you could just leave it there on top. But it is on top. It is not on the bottom. So you can put so you can just cross out the CGs since one is on top and the other one is in the bottom. And now I just have ml. So the answer here is just going to be a matter of using the scientific calculator. So here we go. 1 scientific notation button, -2, or in my case 2 negative, times 1.5 divided by 2.7. Notice I'm ignoring the 1s because this is all multiplication and division. The 1s don't matter. So 0.055555. Now how many significant figures are there here? Well, there are 2 significant figures in this measurement, and there are 3 significant figures in this density, and so the answer can only have 2 significant figures. 0.0056 would be the answer here. This is not going to be the same answer for you. You're going to have, I think, different numbers. 0.0056 ml. When you type in Canvas for this homework assignment, please do not type the ml, just type the 0.0056. You could also type this in like this. 5.6 e minus 3 with no spaces. That would be scientific notation for this number right here. Now I'm going to show you number 2. Number 2 is a little weird because I'm asking for, let me give you a clean whiteboard here. Right. Number 2 is a little weird because I'm asking for some strange information. I'm asking for how many kilometers. Yeah, I'm just asking for kilometers. How many kilometers should the car go on 1.7 liters of gasoline? I'm asking for kilometers. Now I've got a lot of numbers here. I've got 57, I've got 1.7, so I don't know where to start. Since I don't know where to start, I'm going to start with the thing that I want. In other words, kilometers. So I'm going to write kilometers here. That's where I'm going to start. So what do I do with these kilometers? Let's see. Here's something I could do. Here's a conversion factor with kilometers. 1 mile. 1 mile is 1.609 kilometers. So 1.609 kilometers is 1 mile. That's something that I could do. Now let's get rid of these miles. Oh, here we go. 57 miles per gallon. Now this 57 is not by itself. It's 57 miles per gallon. So I go 57 miles per 1 gallon. Right? This 1 comes from the same place where you saw it coming from in the Math Review Part H video. Now, the miles cancel, so I've got kilometers, but I've got gallons. I don't want gallons. I just want kilometers. So here's gallons. 1 gallon is that many liters. So 1 gallon is 3.78541 liters. All right, so the gallons cancel. But now I've got liters, so I've got kilometers and liters. I only want kilometers, and here we go. 1.7 liters of gasoline. There it is. 1.7 liters. That's a 1. And this number is not related to anything. It's just 1.7 liters, not liters per or anything like that. So the liters cancel out, and now it's just a matter of using a calculator here. 1.609 times 57 times 1.7 divided by 3.78541. I'm getting 41 point some stuff. Now let's see. These conversion factors are definitions. Do you see the equal signs? Those are definitions. So I don't care about significant figures there. What I care about is the measurements. 2 significant figures on this measurement and 2 significant figures on that measurement. That means the answer is 41. 2 significant figures. 41 what? Well, all the units are cancelled out, so it's 41 km. But on Canvas, please don't write the km. Just put 41. That's how you do it. Thank you. Oh, it's not going to be 41 for you. The numbers are going to change for you, so you're going to have a different answer. Thank you.